Okay guys, now we're going to be going on to proofs. Okay, so in this section I'm going to show you how to prove that two figures are similar. Okay, so this one requires you to be very careful and very close and see how I prove my working out, because my working out is going to be a little bit more longer. Well, not really longer, it's going to be more of a wording answers, sorry. So I've got to give some reasonings to prove for my answers. So watch carefully and see how I do the provings. So let's get started. Starting with question 4a, it says prove that triangle APQ is, now this three vertical lines that simply means similar to. Okay, so the three vertical lines are similar to. If you see the horizontal three lines, that means it's congruent to. Okay, so this one is similar. Now triangle APQ is similar to triangle ABC. We have to prove that. So triangle APQ is this triangle here. Yeah, and triangle ABC is the bigger triangle, just like that. Okay, hope you can see distinguish the two triangles. Now, okay, so we're going to prove that two are similar. So see what properties we can use. Okay, first of all, I know that this is parallel, so we might not use that. I know that this angle is overlapping, so that's going to be a common angle. Now they give me some sides, so I might use that. So I'll show you my first bit of working out. I'm going to say that angle APQ is equal to angle ABC. Angle APQ, which is this one here, and angle ABC, which is this one here. And the reason why I use that is because I'm given that these two lines are parallel, so these angles must be corresponding angles. And when you're saying the corresponding angles, co-anterior angles, alternate angles, it's actually very important for you to tell me or state what the two parallel lines are. Okay, so we have to say corresponding angles where PQ is parallel to BC. So just use some symbols, guys. Angles, you don't have to write the word out, just use some symbols like this. That one is angle, and this two vertical lines means parallel to. Okay, so you know that PQ is parallel to BC, so I know that it's going to be corresponding angles. Okay, so that one's my first reasoning, and the three reasonings is what you should be giving. Okay, so my second one is that similarly, angle AQP, which is AQP, this one, is equal to angle ACB. ACB, that one there. And what do you think? You're similarly, so it means with a similar reason. Okay, so this is parallel, so these two are also corresponding angles. Okay, so I've actually stated it already here, so I just wrote similarly, so I don't have to write the whole thing again. So you can do that, guys. Now, my third reasoning. Now, I don't really need to give a third reasoning in this case, because it's obvious that if two angles are the same, the third angle must be the same as well because of angle sum of triangle. I would actually state that, but it's not really necessary to do that. So teachers probably won't lose marks for that, won't lose your marks for that. But I just did it just in case. So I wrote angle A is a common angle. So they share that angle, it must be identical. So triangle APQ is similar to triangle ABC because it's equiangular. All angles are equal. Okay, so the important thing here, guys, is that I gave a reasoning for every step. Okay, so if you're stating something, you must give a reasoning and tell me why you think that's true, just like I did there. Okay, and even in my last step, I said that because of the equiangular triangles. All right, so have a good look at that one. It's important for you to write this logical working out. Now, just before we move on, I just want to state that if you don't set out your working in a logical manner or a very clean way, you will lose marks. Teachers will get your marks down if you don't write it neatly or if you don't have it in the nice structure that they can understand. Okay, so please don't make it confusing for yourself and the teacher. Trying to keep it logical as you can. Alright, that's question A. If I move on to B, it says hence find PQ, AQ and QC. Okay, so I'll just go over the things that we need. PQ, AQ, we need this one, squeaky pen. QC, this one. So I'll just put like this here so I can distinguish the lines. So that line, and that line is what we're after. Okay, so have a look and let's try to get started to find the values, because I think I can do that because I've got some sides given to us, right? And similar triangles, their sides are in proportion, so we're going to try and use some ratios here. Okay, now PQ over 27, so I'm doing PQ over 27. This side in the smaller triangle corresponds to this side in the larger triangle, so it's going to be PQ over 27. And then it's equal to, we're going to find another pair of corresponding sides. So see how PQ is a side in the smaller triangle? So let's find another side in the smaller triangle. And I put 10 because I'm given that this side here is 10. Yeah? So it's 10 over, what's the corresponding side in the larger triangle that matches with this side? It must be this whole side. Make sure you don't just write 8. It's going to be this whole side, which is 10 plus 8, which is 18. So do you see how I did that? Now all I need to do is simply multiply both sides by 27 to have PQ left on my left hand side and calculate it. You should have 15. Okay, so PQ is first of all 15. So we found PQ, I'll just label it 15. Okay, alright, now I'm going to go ahead and find my AQ, and I'm doing the same thing, AQ over 22.5. See how this AQ is one side, this side in a smaller triangle. Now the corresponding side in the larger triangle is this long length, which is, it's given 22.5, so I'm writing 22.5. And remember, we need another pair of corresponding sides so I can just make the ratios. So I'm just simply, see how I use 10 over 18? I'm just going to use the same ratio, 10 over 18 here. Doesn't really matter which pair. Okay, so I've got one pair, I can just use it for all of the questions. Okay, so I've done that. But again, when you're using these ratio with the same ratio, make sure the AQ and 10 are the same as other sides in the same triangle. Okay, they must correspond. Okay, now to find AQ, multiply both sides by 22.5 and just calculate that. You should have 12.5. So I found my AQ. Okay, so this length here is, what was it? 12.5. 12.5. Okay, so I found my AQ. Now, so the last one I need to find is QC, which is this one, this length here. Yeah, so let's go ahead and find that. Now guys, this time, I mean, you can use this ratio thing if you like, but have a look. I've got this full length and I've got AQ, this part of the length. So to find this length here, I can simply do 22.5 minus 12.5. Okay, that length minus this length would be that length there. So I'm going to do that simply, and then I can find QC. It's going to be simply 10. So I found all my values of the lengths that I need. Okay, so that's PQ, AQ, and QC. And see how I got the last one very, very easily? So make sure you always find the simplest way and fastest way to find your answer. That was question 4, so have a look and check your answers. Let's move on. Question 5 says prove that triangle PQR is similar to triangle TSR. So triangle PQR is this triangle here, and triangle TSR is simply this one here, and I don't really need to distinguish the colors because it's just so obvious, right? The two triangles are just there for you. Okay, so now that I've got that, let's go ahead and prove that they're similar again. I'm going to start off by saying that in triangle PQR and triangle TSR, it's a good idea to start like that so your teachers know that we're going to be using these two triangles. Okay, so just it's a good idea to have an introduction, the body, and the conclusion. So this is my introduction and my body is going to be my reasonings. So I'm going to start off by saying angle PQR, this one here, that one, is equal to RST. RST. So this one is RST. And why do you think they're equal? What's the reasoning? Now I hope you can see that this line and that line is parallel. So these two angles must be alternate angles. And what are the parallel lines? PQ and ST. So you should state that PQ is parallel to ST. Okay? Now my second reasoning is that angle PRQ, this one here, is equal to SRT. SRT, this one here. And why do you think that, guys? What's the reasoning? Vertically opposite angles. See how those two angles are vertically opposite when the two lines cross? So vertically opposite angles are always identical. Alright, so have a look. And then I can say that, therefore, triangle PQR is similar to angle TSR. Now, if you have the time, I would suggest you to write the third one, saying that the third one would also be same by using angle sine of a triangle, or this last one is also alternate angles, isn't it? So you can say alternate angles. But I didn't write it because it's obvious that the third angle must be same, because angle sine of a triangle. So that's all I did, to make a little conclusion always. And I'll also write equiangular here. Or you can simply write AAA if you want to. Okay, teachers would understand that. AAA means angle, 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 all angles the same. Okay, so I would actually write that as my concluding statement. Okay, so two pairs of matching angles are equal. That's just simply same as equiangular AAA. So that's my full working out. So have a look at that one. Yeah? And now you don't have to write like that. I would suggest you to you can write that, but I would suggest you to find the quicker way. So AAA or equiangular. So let's move on. Hence find the value of n. So we're going to find the value of n, which is this one here. So let's go ahead and find it. Now we know that the two triangles are similar, so we're going to use that the two triangles are in the same ratio, the sides. So let's go ahead and do that. I'm going to say that QR over SR, which is this one. So this side is corresponding to this side in the smaller one. So QR over SR is the same as PR over RT or TR. So do you see that? So that over that must be equal to that over that. Same thing as we always did, yeah? So I'm going to put in my values. Because matching sides are in proportion. Okay, so I just stated a little reasoning for that. And then n over 12. So QR is n. SR is 12. PR is 15. And TR is 10. Do you see how I did that? Just put in the values. Just multiply both sides by 12 to get n left on your left hand side. And that should be just 18. Okay, so n is 18. And this is just our usual process, isn't it? So I hope you're getting the hang of this already. Okay, that's question 5b. Okay, question 6. Prove that triangle QTR is similar to triangle STP. Alright, this one's maybe a little bit more confusing. Have a look, because see if you can identify the triangles. QTR is this one here. Just trying to outline it. And my STP, where's S? Oh, here it is. Ah, that was very crooked. STP, that's the STP. Yeah, so this is the two triangles there. So I'm going to prove that these two triangles are similar, sorry. And let's see how I'm going to do that. Well, QT, I'm going to start off by doing some ratios because I don't know if I have enough angles to prove it. So I'm going to say QT over TS, QT over TS, okay? So see how this side in the smaller triangle is corresponding to this side in the larger triangle? Okay, and you're going to know how to distinguish that, because make sure you don't say that corresponds to that. Because see how 7.2 is larger than 4.8? So, and see how 9 is larger than 6? So the larger ones must correspond with each other and the smaller ones must correspond with each other. So make sure you know how to distinguish that first. So I did that. QT over TS would be equal to 7.2 over 9, because in here 7.2 is QT, TS is 9. So I just got that ratio for the first part. Now, which is, okay, just simplify it, I'm just multiplying top and bottom by 10 to get rid of that decimal. So that's going to be my ratio for QT to TS for one of the sides. Now also, which is 4.4 over 5, to simplify as much as possible. Now RT over TP is the other two corresponding sides. RT over TP, which is 4.8 over 6. Okay, and again multiply both top and bottom by 10 to get rid of the decimal, and then just simplify. You should have 4.4 over 5. Now look guys, can you see that that's the same ratio? So I'm going to say that angle QTR equal, that's just another reasoning. This is one reasoning. Now moving on to the second angle. Angle QTR equals to angle PTS. So this angle here, that angle there. And why do you think it is, guys? Vertically opposite angles. They must be equal. Okay, now my sides of that angle, equal angles, are in proportion, which is from here. See how the sides are in the same proportion, which means it's in the same ratio. So I proved that this one is equal to this one. So that's already two sides proven. Okay, so I can conclude that the two triangles are similar. Alright, so this is one reasoning, this is one reasoning, and both makes a reasoning because both of them are equal, which means they're in proportion, and we've also proved that an angle is same. Okay, so when you're proving for similar triangles, let's say if you have this triangle and this triangle, you want to prove that they're similar, you can either prove by doing the equiangular AAA one, or if you don't have enough angles, if you can prove that at least one angle is same, maybe that one and that one, and prove that this side, these sides and this side corresponds and are in the same proportion, so see how the two outer sides, then that also makes a reasoning. Okay, that also makes a proof. Alright, so hope you know the different ways of proving the similar triangles or similar figures. Okay, question 6b says, hence prove that PQRS is a trapezium. So see how this PQRS, this shape here, is a quadrilateral. Now it's asking us to prove that it's a trapezium. Okay, now it doesn't look like a trapezium, but we're going to prove it. Okay, now what's the basic property of a trapezium? The main property of a trapezium is that opposite sides are parallel, and only one pair of opposite sides are parallel. Okay, just one, if one pair of opposite sides are parallel, then we can prove that that's a trapezium. Now we have QR and PS, which is a pair of opposite sides, and we also have QP and RS, which is a pair of opposite sides. So let's see if we can prove that one of them are parallel. Now I'm going to start off by saying angle RQT is equal to PST. So this one and this one here. Okay. Now I know that they're equal because matching angles in a similar triangle, in similar triangles. If remember how I proved in part A that these two triangles are similar, therefore the angles must be equal, the corresponding angles. So see how this angle, and guys, make sure you don't get confused, make sure you can be able to distinguish which angle corresponds with each other. So make sure you don't say that corresponds to that one, because this is the angle next to the larger side in the smaller triangle, and this is also the angle that's next to the larger angle in the larger triangle, bigger side in the larger triangle. Okay, so that's how I know that those two are going to be the equal angles. Now I'm going to say QR, this one here, is parallel to PS, just like that. And how do you know that? Because alternate angles are equal. And see how these lines, these angles, look like alternate angles, don't they? Now the only way they can be equal or they can be alternate is when these two are parallel. So these two lines must be parallel in order to make these two angles the same, because they're alternate angles. Okay, so that's my reasoning. Now I can say that, therefore, PQRS is a trapezium. Because I proved that one of the pair of opposite sides are parallel. Okay, I proved that QR is parallel to PS, so therefore it's a trapezium. Okay, so it's very simple. It's very simple as long as you know the property of a trapezium. That was the very main property of a trapezium. Okay, so have a look and let's move on. Question 7 says prove that triangle CDE is similar to triangle GFE. Okay, so I think you can distinguish the triangles. I won't go over it because you can see that that is CDE and that is GFE. Okay, let's go ahead and prove it. I'm going to start by saying that in triangle CDE and triangle GFE, this is my first reasoning. I'm going to use some ratios. DE over EF. DE over EF. Okay. This side in the larger triangle corresponds to that side in the smaller triangle. And you can see that because this is the 18 and 24 other sides in that bigger triangle, but 18 is a smaller one, and 15 and 20 are the sides in the smaller triangle, but 15 is the smaller side. So the smaller sides must correspond with each other. So DE is 18, EF is 15. Just simplify that, 6 over 5. Okay, and I know this because it's the given information, isn't it? So just write that it's given. Now I'm also going to say that CE over EG, CE over EG, so the two, oh, that was a bad line. CE over EG, that's the other two sides, remaining sides, and that's 24 over 20, isn't it? Simplify it, you should have 6 over 5, and I know that this is true because the sides are given to us. So I just wrote given just to give a very good reasoning. Now, so I've proved that the two sides are in proportion, which is good, so see how they are equal. Now I'm going to say that angle DEC, I'll just rub this off now. This is DEC, and angle FEG. Why are they equal, guys? Of course you know it's going to be vertically opposite angles. So I've got my three reasonings. I'm going to say that, therefore, triangle CDE is similar to triangle GFE because two pairs of matching are in proportion. Well, this should probably have a sides in it to make it more clear, and the included angles are equal. Okay, so remember how I said the two outer sides, you should prove that they're in proportion, as well as the internal angle, the middle angle must be the identical in the two triangles. Okay, so I've done that, so I've proved that the two triangles are similar. Easy, isn't it? So have a look. And let's move on to B. B says, hence find the value of x. Okay, so I know that this triangle and this triangle is similar. So if I want to find the value of x, I must compare some of my angles. So I'm going to say that angle CDE, which is the x there, must be equal to angle GFE, which is this one here. And what's the reasoning for that? Matching angles in similar triangles are equal. Okay, so that's the matching angles. And because they're similar triangles, the angles must be identical, right? So that's what I'm going to be using. So therefore, x must be equal to 47 because CDE is x and GFE is 47. So that's it. I found x. So it's very, very simple as long as you know that they're similar. Let's move on. Question 8 says AD is parallel to XZ, parallel to BC. So I hope you can see that AD, XZ, BC, they're all similar. Parallel, okay, parallel. And X is the midpoint of AB. So see how this is AB? X is the midpoint. Now, AD is 6, so AD is 6, and BC is 10. So I'm just going to label that. Okay, now part A says prove that triangle AXY is similar, because 3 strokes, so similar to triangle ABC. Okay, so AXY is this triangle here, and ABC is that triangle there, but my line's a bit out, but I hope you can see. Okay, so I've got that. Now I need to prove that the two triangles are similar. So I'm going to just start by proving an angle. Angle AXY, this one here, must be equal to ABC, this one. Yep. Now can you see that these two are parallel? So what kind of angles are those? Why are they equal? Because they're corresponding angles, where the XZ, this one here, is parallel to BC. Okay, so that's what I'm doing. Now I'm also going to say that angle A is a common angle. See how they share that angle there? So I'm going to say it's common. And then obviously the third side must be the same because it's angle sum of a triangle, so therefore the two triangles are similar. Okay, I just used the equiangular reasonings. Alright, so that's my working out for, oops, I've actually rubbed out the 6 and 10, didn't I? Yep, so I've got that. Now B, it says show that Y is the midpoint of AC. So this is a unique question. It says Y, this one here, you have to prove that that's the midpoint of AC. Now remember how X is the midpoint of AB, so I'm just going to put that is equal to that. Okay, let's see if we can start doing the working out. I'm going to say that AY over AC, okay, see how AY is a side in the smaller triangle and AC is the corresponding side that's in the larger triangle, so AY over AC. So I'm going to do the same thing with the other ratios. AX, okay, is a side in that smaller triangle, and AB is the corresponding side in the larger triangle. So I'm going to put AX over AB. Now you know that this is definitely going to be true because in similar triangles, the sides must be in proportion. So this ratio must be equal to this ratio. And you know that X is the midpoint, so this is exactly half of this, isn't it? So the ratio is a half. And that applies for AY over AC as well because similar triangles have sides in the same ratio. So I've got my ratio of those two. Now I'm going to say that matching sides are in proportion, as I always say. Now X is the midpoint of AB. That's what I'm going to be that's what I already used in this one. So this big one is 2 times AX because X is the midpoint. And now I'm going to say that AY over AC, which is this one that I used here, AY over AC. Now I'm going to use that one because Y is involved. See how Y is within AY and AC? So that's why I'm using that ratio. So AY over AC is also going to be half because of this reasoning. So therefore Y is the midpoint. Because this ratio, this to this is also half, that means this one is a half of AC, or vice versa, AC is 2 times AY. Therefore, Y is the midpoint. Okay, if the ratio is a half, that Y must always be in the middle, midpoint. That's the reasoning. Okay, so do you understand that one, guys? It's a unique question. It's a very typical exam type question. Yeah, so have a look at that. That's question 8. Okay, now I'm going to go on to C. It says find XY. XY. This one here. So how are we going to find that? And I rubbed that out again, didn't I? 6 and 10. And I know that that's equal, that's equal. Okay? Because Y is the halfway mark. So if I want to find XY, this one here, what should we do? Well, I'm going to start by saying XY over BC. XY is the smaller, well, XY is the side in the smaller triangle, so the corresponding side in the larger triangle must be this one here, BC. Yeah? And that's equal to AX over AB. Yeah? Because AX is a side in a smaller triangle and AB is a side in the larger triangle, corresponding side in the larger triangle. And we know that that's half, isn't it? Yeah, we used this in the previous question. It's also going to be half because x is the midpoint. So I'll say that. Matching sides are in proportion. Okay, and now xy over 10, I'm just simply using this ratio here. And now I know that BC, this one, is 10. So I just replaced it with 10, and that's going to be equal to a half. See what I'm doing, guys? Now see how the only missing value or unknown value is xy. So all I need to do now is use some algebra to find that value. Multiply both sides by 10 and you should get 5. Because half times 10 is 5, so therefore xy is 5. Okay? So I'll write that down. This one is 5. Okay, so have a look. That's question C. Now D says prove that triangle CZY, so I'll just go over that one. It's getting messy. CZY is similar to triangle CDA. CDA, that's CDA. Okay, sorry about my messy triangle. Can you see that, guys? That's the two triangles that I'm going to prove are similar. So I'm going to start off by saying angle CZY, that one, is equal to angle CDA. CDA, so that one there. And what do you think, guys? You should be really good at this. Corresponding angles. Okay, see how those are corresponding angles where this and this is parallel? So just put that there parallel. Now, angle C, this is a common angle because see how they share that angle? It's overlapping, so it's going to be a common angle. Now, therefore, because I've proved that two angles are equal, the other third angle must definitely be equal, so therefore the two triangles are similar by using our equiangular reasonings. Okay, now E, find YZ. YZ, so I'll kind of rub this off so you can see my okay. So that's my given information. That's all the given information there, and all I need to do is find YZ, that one there, that length there. So let's go ahead and find that. Now YZ over AD, see how I'm using YZ because I need to look for that. YZ over AD, see how YZ is a side in the smaller triangle and the corresponding side in the larger triangle is AD. So I put it over AD. Okay, now that's equal to CY over CA. Remember CY over CA? Remember how I told you that we found that Y is the midpoint of CA? So therefore CY over CA, we definitely know that the ratio is half. Okay, now you know that these two are equal because matching sides in the similar triangles are in proportion. Yeah? So they must be equal. So if CY on CA equals to half, that must also be equal to half. So I'm going to do that. YZ on AD equals to half, but I just replaced AD with 6 because I know that AD is given that it's 6. So now multiply both sides by 6. Well, okay, Y is the midpoint of AC, you know that. Okay. That's just giving a reason to show you why this over this is half. Okay, so sorry, that was my fault. You should have given a reasoning. Now go and multiply by 6. Half times 6 is simply 3. Our value of YZ is 3. Okay, so see how I did that? So make sure you get used to this kind of idea, how I use the ratios of the matching sides. Okay, and if one matching sides are in some ratio, another pair of matching sides must be also that ratio because, as I said, matching sides are in proportion. Okay, so hope you're getting the whole idea of this. It sometimes get confusing, but you kind of got it, don't you? Now F, final part, it says hence find xz. Oh, I shouldn't have actually rubbed it off, but anyway, xz is this whole length here. Okay, well, we found that this one is 5 from our previous part. I can't exactly remember, but one of the previous sections we found xy, haven't we? We found that that's 5, and we found that yz from our previous one, E, is 3. Yeah? So we know that that's going to be 8. The value of xz is simply 5 plus 3, which is 8. So this step is just like very, very easy. It's nothing that you don't know. So see how I got that, guys? That's our question A. It was a long question. It's got up to A to F, but you get all of the steps, don't you? And I think the only different one here is the using the ratios, okay, and using how the ratios are equal. Trying to get the idea of that way, okay, because that's used very frequently with these questions. And this is a very typical exam type question, so you got to get used to this type of question, okay? That's question A. Let's move on. Question 9a says prove that triangle SVW is similar to triangle UTS. So you can actually distinguish the triangles, can't you? That triangle and that triangle. Okay, so I've got those two triangles. Let's see if we can prove that they're similar. Now let's see what reasonings we have. Well, in these two triangles, just give an introduction statement. I'm going to say that angle SVW is equal to UTS. SVW this one and UTS this one. See how they're given that it's 90 degrees, the right angle? So it's given, so I've got my first angle very easily. Now, I'm going to say that I'm going to use my ratios now because I don't have any more angles to prove. SV over TU. Where's SV here? SV over TU. See how SV is a side in a smaller triangle and TU is the corresponding side in the larger triangle. So SV over TU equals to 12 over 15. Now that's simply going to be 4 on 5 simplified, and we know that that's true because of all the given information there. Okay? Now I'm going to see if I can prove another side. So SW over SU. SW is this side here and SU is this full side here. Okay, so see how SW is the hypotenuse in the smaller triangle and SU is the hypotenuse in the larger triangle. Can you see that? So that's what I'm doing. So SW is 16 as given and SU is 16 plus 4, which is 20. Make sure you add them together. And simplify, which is also 4 on 5, and we know that because of the given information. Just write given. And guys, you can see that this is equal to this, so we know that they're going to be in proportion. So, therefore, the two triangles are similar. Okay, so we've proved the two sides and the inner angle. Therefore, we've finished the proof of that one. Have a look. So hopefully you're getting used to how we prove. It's very repetitive, isn't it? Now B, hence prove that SV is parallel to TU. SV is parallel to TU. We're going to prove that these two lines are parallel. And you're going to know that it says hence, so you're going to use the property of similar triangles. You know that these two triangles are similar, right? We've proved it in part A. So I'm going to say that angle VSW, this one here, and angle TUS, this one here, they are same because this angle corresponds to this angle in the larger triangle. Okay, so see how that's the angle between the two sides, and that's also the angle between the two sides, which is the side and the hypotenuse. So that's going to be the angle that's going to be equal. Now we know that because, as I said, matching angles and similar triangles are equal. Now you can prove then therefore that SV is parallel to TU. Okay, SV is parallel to TU. And what's the reasoning for that? We've actually done a similar one before. Alternate angles are equal. See how these ones look like alternate angles where these must be parallel. These angles, for them to be parallel, these two lines must be parallel for them to be alternate, sorry. Okay, so that's why SV is parallel to TU, so we've finished the proof. Okay, so it's as simple as that. So have a look. As long as you find one matching angles, that equal angles, then you can probably find them at the parallel sides. Okay, see that, guys? So have a look. And that was question 9.